Hey kids, before we move on, what we want to do is we want to figure out why area is measured in squared units. Now what I did is I have all of these shapes and we drew them on graph paper because this graph paper contains a bunch of squares. So if I take a look at this rectangle, here I have a base, here I have a height, and you guys remember that the area equation is base times height. Well, I just don't multiply any two numbers together. I make sure the numbers that I am multiplying together is perpendicular to each other. So if I take a look at base and height, it contains all of these little squares that fill up the shape. So if I go through where here the base is 7 inches, let's say the height is going to be 4 inches, and if I multiply 7 inches by 4 inches, that gives me 28 inches squared, or basically 28 squares that fill up this rectangle. And the same goes true for triangles. If I am working with this triangle, I want to make sure that the base and the height are going to be perpendicular to each other. Now, if I take a look at this, the area equation is 1/2 base times height. So here the base is 6, here the height is 6. So if I multiply those together, this would give me 18 units squared. Basically, there's 18 squares inside this triangle. Now for a trapezoid, remember I have two bases. So I got base 1, I got base 2, and the equation is 1/2 the height times base 1 plus base 2. But I got to remember the relationship of the height, that it is perpendicular to both the bases. Now finally, I have over here a circle, and the circle, the area equation is pi r squared. Now this r squared can be drawn like so, where here I have a radius and a radius, and when I multiply those radii together, I will get all of these little squares times pi, which will give me the area of the circle. So I got to remember that I'm not just multiplying any old numbers together to get the area. Those numbers, we are looking for a perpendicular relationship, and that will tell me how many squares are going to fill up the shape. So now we're going to move into an alternate way to find the area of a square, rhombus, and kite. Now we know that a square, these sides are perpendicular, so if I have side and side, the area is going to be side squared. But there's another thing that we can do in order to find the area of a square that is the same with a rhombus and the same with a kite. So if we're going to go through and talk about that, we got to remember the relation of the diagonals in each of these shapes. So if I draw in the diagonal here and the diagonal here, we get a relation that is going to be the same as the diagonals over here and is going to be the same for the diagonals in a kite. Now, do you remember what they are? If you said they're all perpendicular, you are 100% correct, because what we have here is three shapes in which the diagonals are each perpendicular to each other. Now, what I have here is the formation of right triangles. So a square and a rhombus both have four congruent right triangles, where a kite can be looked at a little differently. I do have four right triangles where 1 and 2 are going to be the same to each other, and 3 and 4 are going to be the same. Or I can take a look at, for a kite, the relation of what kind of triangles. For instance, this triangle up here is going to be an isosceles triangle, and then this big triangle over here is going to be another isosceles triangle. So we can take a look at a kite as either finding the area of each of these four right triangles and adding them together, or I could find the area of each of these isosceles triangles, this one on the left and this one on the right, in order to find the area. So what I got to remember is that there's more ways than just base times height when we are finding the area of these shapes, because I'm not always going to be given the base and the height in order to find this. Sometimes I'm going to be given information about the diagonals. Now let's do an example in which we find the area of a square given the diagonal of length 12. So let's draw on that diagonal. And I know that that diagonal is going to be 12. Well, by what we just talked about, the diagonals in a square are perpendicular and they bisect each other and they're congruent. So what I know is I have this information for the square. So what I can do is I can find the area of this triangle, which is 1/2 times base times height. The base is 6, the height is 6 because they are the sides that are perpendicular to each other. And then this will give me 18 units squared. Now remember, that is one triangle. So if I do 18 times 4, that'll give me 72. I don't know why I wrote a 3 there. That'll give me 72 units squared, which is the 4 triangles. That is one way of doing it, and now there's a second way of doing the same problem. So what I need is a square, so let's kind of bring out a square here. Okay, so now going through the same problem, I have this. The diagonal is 12. Here's a side, and there's another side. And I can use the Pythagorean theorem. Pythagorean theorem here is going to be side squared plus side squared is going to equal hypotenuse squared. So that's 2 side squared is going to equal 144 divided by 2 side squared equals 72. Now this is the area equation, and it equals 72 units squared. So there's 2 different ways of doing the problem. The 4 congruent right triangles that make a square, and I find all of those. Or I could go through and use Pythagorean theorem in order to solve out this example. And there you go. Just remember a few things. 1, use Pythagorean theorem if need be. 2, your properties of all of the diagonals in the shapes. And 3, your area equations. Put it all together, try it out. Later.